I recently converted my bandsaw so it can go into a vertical position. Now I need a table. There are several clearance issues, so I'm going to have to make a sliding dovetail system. I'm making an MDF template just to check clearances. Checking clearance at the bandsaw, I can immediately see some issues. I've really got two options here. I either cut a big chunk out of the table to accommodate the cylinder, or I move the cylinder itself. This cylinder is going to hit this column, so I'm going to have to move this column. I'm thinking about that. To move the control box where I want it, I'm going to have to make up a special mounting plate. A bit of quick work at the mill and this part is ready. I'm just putting one stud in here just to tighten it up and hold it in place. I shifted this cylinder off camera. All it took was an extended mounting plate and a longer quick release pin. And as an added bonus, the cylinder lays right back and clears the entire bandsaw mechanism. Now that I've confirmed the table will fit, I can get to work. It looks like there's extra clearance, so my steel table is going to be bigger than my MDF template table was. This is not a conventional work holding method, it's more an experimentation by me. This mag chuck was recently restored in a video. Click the card if you want to see that. As a work holding method, the mag chuck worked, but it did slip on me and I had to be very careful with cuts. I got the plate reasonably flat off the mill. For a bandsaw table it would be perfectly acceptable. I'm not happy with the rough surface that the face mill left, so I'm going to take it over to the surface grinder. And I might as well try and get it flatter. Now I'm still learning with surface grinding, so I might as well practice grinding a large flat plate. So this is pretty interesting. Went back to the surface plate and remapped the bottom side. There's kind of these two high spots here and here. I'm probably not going to get this any flatter without running coolant. Where I can see there's obvious low spots, I'm putting paper shims in. I'm placing these paper shims down to match with the contours that I marked out on the plate. Rather than using flood coolant, I've just taken to using a spray bottle because it makes less mess and it doesn't go foul in a coolant tank. So the good news is we've maintained mount distortion. It means all of the shimming has managed to preserve this side entirely. So I haven't introduced any additional warp that I can't explain. So technically, if we lightly take this side down, we should have two flat and parallel sides. Considering it's surface ground, it's not very flat. For a bandsaw table, I'm going to accept it. Continuing the experimental work holding, I'm now going to use these low profile clamps I made in a recent video. I'm planning on just squaring up the external perimeter. Now my mill has limited capacity. I'm going to have to switch over to horizontal milling in order to reach the edge of the plate. Now these low profile clamps have no downwards holding capacity. I could put a strap clamp on, but I like to live dangerously. I want to point out the feed direction of this face mill. All the cutting action is driving this plate down into the table. If I fed the other way, it would be launching it up into the air. And that would be a bad thing. After the four sides were square, I pecked two holes in the edge, and then I reamed them. I'm feeding very carefully because these are blind holes and this is actually a hand reamer. It really shouldn't be run under power. The table is going to be adjustable with a dovetail clamping system. Now let's make the dovetail jaws. Chop chop. Off camera I made up this precision guide rail. The idea of this rail is I can clamp it down to the table and then have some floating strap clamps that I can put onto my workpiece. And that way it gives a repeatable setup for multiple workpieces, like what we're about to do. So I went through the process of tramming in this guide rail and bolted it down. Because I'm cutting right to the bottom of this piece of stock, I'm putting a parallel under it and it's got a slight air gap. I don't want to cut into my mill table. I'm going to be using my 60-degree dovetail cutter, which was one of my first tool making projects. Alright, time for a new plan. I can't work on this side, so I'm going to flip it over, work on the other side. This dovetail cutter is only a single flute cutter, and because of this I have to be fairly conservative with feed rates. But it does an okay job. And that's the fixed jaw complete. And now for the moving jaw. Now I need to work on the top plate. This is going to be the actual working surface, and this is the part that will slide in the dovetail jaws. As with the bottom plate, we milled it and then we ground it. I need some sort of locking knob and a screw, so let's make that. These toolmaker vices have these V-grooves in them. I can use that to set this. The one thing I don't like is these hardened jaws actually mark this and they'll leave 2 lines on this. And now to assemble everything. Off camera I tapped some dowels into those reamed holes, and that makes for a nice guide for our moving jaw. Now that I've got this plate, I push the jaw in, clamp it down, and I know the jaws are true. And now for the moment of truth. That's awesome, it holds. So the table is going to go about here. It is going to be pushed further forward though. You need some table in front of the saw to guide the workpiece in. So I need to cut a slot in both top and bottom plates. Nice. In terms of mounting, I've got this casting here. So I think if I build off these 2 points here, this is adjustment for the blade built into it, so I don't want to mount off this. This guard is going to be a problem. If I sit the table above it here, the table comes through and it hits the back of the vise. So I'm going to remove this guard and sit the table about at this height. That's in the hole. I need to jack this table off the casting by a certain amount, and to get a feel for how much I need, I'm just inserting gauge blocks one by one, just to get an idea.
In gauge block bingo, 25 is our number. I made these standoffs off camera, now to try them out.
Well, that's pretty average. This casting isn't flat and true to the blade. So the top of this needs to be cut at an angle in order to set the table at the right angle. Quick modification to this guy. We've now got a high side and a low side. And it's better. I think I'll just go back and trim a bit more and get that right.
So I'm about a quarter of the way through this plate, and then it dawned on me, why don't I cut this with the bandsaw? I need to deburr this, but I'm really keen to try this out now. Woohoo! Got a vertical bandsaw! Now, one thing that's going to be a problem with this is going to rust like crazy. So I need to do something to treat this. I've got a few anti-corrosion experiments going on. I'm going to run with timber wax spray. A quick test with the spray bottle. The water beads on the surface and rolls off. Hopefully that will prevent corrosion. And I can still use it as a horizontal bandsaw even with the table installed. So that's really cool. We've now got a bandsaw table. In the next video we'll try and get this truly vertical, because at the moment that happens. I also need to address the holes that I butchered out of the back. I'm also going to open up the cabinet to make some storage. I have improvements that I want to make to the vise. I'm also going to make material in and out feed tables. And there's still a few knobs that I need to fix up. Thanks for watching. Catch you later.